we could do without that feedback.
Yeah. I'm Ben. I'm the chair of the Friends of the DAO. We are the organization that operates the Center of the Universe on behalf of the National Research Council, who we have a relationship with. They're our landlords, essentially. The rent is very reasonable. I would like to acknowledge that we are on the land of the Senchothan-speaking peoples of the Coast Salish nations, and with whom we hope to build relationships going forward, not just work and knowledge there, stewardship of this land. The hill is called Utixis in the Senchothan language. I have the great pleasure of introducing Mary Beth, and I have my notes that I need to find.
Notes?
I have notes. Well,
Hey.
you should know. You wrote them. Yeah.
I always forget about this part.
Mary Beth is a great friend of the Friends of the DAO and the Center of the Universe. I found out on Thursday night that she first met us only 2 or 3 months after we started up in the summer of 2015, and she's been quite a frequent visitor to the center, and she's done everything but talk to us, perform, do teacher workshops, and even donate prizes for our raffles. So with the aid of the Canada-France-Hawai'i Telescope. Her official title is Director of Strategic Communications at the Canada-France-Hawai'i Telescope.
I'm sorry, I didn't update my phone.
Oh, all right.
That's my title.
Oh, really? Even better.
I'll explain it.
Yeah, okay, well, that's good. That sounds better anyway. Yeah. She runs a Maunakea Scholars program and an innovative astronomy outreach program for Hawaii public school students. Mary Beth has an undergraduate degree from Penn State University in astronomy and astrophysics, and a master's degree in education technology from San Diego State. She is going to tell us all about what's happening in Hawaii these days.
Yes.
Thank you, Ben. It's always awkward when I wrote my own bio wrong. So as Ben mentioned, this is not my first visit to the Center of the Universe. My actual last work trip before the pandemic was to the Center of the Universe and Victoria. I was late February of 2020. And I remember that because, well, the world shut down, but my sister and her family were visiting, and my brother-in-law had a conference on Maui, and they flew back, and they were like, there's just this flu in Japan. And so all of the Japanese visitors that were supposed to be there canceled. And as the weeks went on, they were there for 2 weeks, like by the time, and then the world shut down for 3 years. So it's been almost slightly over 3 years since my last visit. So thank you for the introduction, Ben. I will have to make sure that I update my bio. My title is Director of Communications and Community Engagement. It's the same job. It's a different title. I explain space to people for a living. So regardless of what you call it, it's a very good job, and I enjoy it a lot. Please let me know if I'm too loud. I usually don't use a microphone, but I am for all of you online. So, all right. So I want to do a land acknowledgement for Maunakea. So at CFHT, we acknowledge the reverence and importance that Maunakea holds to the Native Hawaiian community. Hundreds of historic sites, archaeological remains, shrines, and burials are on the slopes of the Mauna and its summit. So you'll notice here is a QR code. So we've received a lot of comments. Everybody has opinions on land acknowledgements. And so one of our coworkers just made the suggestion that we should have a QR code. They saw a story about how if you're going to acknowledge the land, you should do something for the land. And so I'm piloting our new QR code. This is a link to our site on Maui. Regarding the fires that have occurred on Maui. And so we've received so many questions, many inquiries about how the people of Lahaina and Maui are doing. And so we just wanted to acknowledge that. If there's anybody who, please don't feel obligated, but if you were looking for an opportunity, this QR code provides that. If you're not looking for an opportunity, we appreciate the support. We got a lot of questions from a lot of our Canadian friends. The town of Lahaina is devastated. They will start to rebuild. The death toll is not going to be as high as anticipated, so that is very good news. And upcountry Kula has kind of been overshadowed by the sheer devastation of Lahaina, but it also suffered quite a bit. And so for all of us who live in Hawaii, we're as a small island state, everybody knows someone. Everyone knows someone who was affected. And so we just wanted to say our gratitude, and we love Maui. Maui strong. So I think this is my map. Please ignore this. I have yet to figure out how I can do the Google map without the price. Anyway, I did that yesterday, so I don't actually know what the price would have been. I just feel like if I'm talking, every good movie that is like a good adventure movie starts with a map. I saw the new Indiana Jones movie. I enjoyed it. It also had maps. And so I live in Hawaii, and there is Victoria. It's always interesting, depending on where I do these talks, how far this one is. This is a short flight at my 10 hours and 10 minutes. And so I just like to start this out to show how far I have come to talk to you all. And I also wanted to acknowledge and respect the First Nations people whose historical relationships with the land continue to this day. That is specifically the land that the DAO is standing on. I have a slightly vaguer land acknowledgement because I'm also going to be giving this talk in downtown Victoria, and I know that there are different peoples for different regions, and wanted to make sure that I incorporated everybody in this talk. So mahalo, just the Hawaiian word for thank you. Mahalo to the First Nations people and the land. So who is CFHT? We're the Canada-France-Hawai'i Telescope. Really, it's all in the name. We are a 3.6 meter telescope on the summit of Mauna Kea. We are a joint facility of the National Research Council of Canada, like steps away. The French equivalent and the University of Hawaii. We have partnerships with Taiwan and China. And it doesn't matter how many times I get rid of that second headquarters located in Waimea, somewhere it reappears. I swear it only had one yesterday. And so for those of you unfamiliar with our lovely state, this is Hawaii Island, also known as the Big Island. Here's Maui. This is where we are located, our headquarters located in the town of Waimea. It is cowboy country. We live up country at about just a little shy of 1,000 meters. So visiting Waimea is not like visiting the coast. We are cool in all respects. It's a neat place to visit. It's also much colder, sometimes 10 degrees Fahrenheit. The difference between the coast and where I live. I live there for a reason. So this is CFHT at the summit. This is my coworker, Greg, at sunset. Greg does not normally stare pensively into the abyss. My other coworker, Tom, was taking the shot, and he thought we needed a sense of scale. So he's like, Greg, go stand out on the catwalk and stare into the sunset. And so this is Greg facing west. We are a 44-year-old facility. The telescope will be 45 next year. And so it has been a partnership between Canada, France, and the University of Hawaii that entire time. This is a picture taken from the summit of Mauna Kea. So Peyton Todd Photography. Peyton was a high school student at the time she took this photo, and this is the Milky Way and the moon. And so the summit of Mauna Kea is one of the darkest places in the world. It's even darker than the Arctic because our location along just above the equator means that we have no aurora. So there's never any sky glow from the aurora. So we are very, very dark. And this is a good night. It's a long exposure. You can tell because the moon is much brighter than the moon normally is. And this allows you to see the Milky Way. So I often get asked, how do telescopes work? So this is a nice time lapse. What you're seeing is our shutter open. I like to say it's like a really large garage door. It is lovingly maintained because we are an over 40-year-old telescope. So I tell kids, if you have a 40-year-old car, you don't just like wait till there's no oil in it and then be like, oh my God, there's no oil in my car. You do what we call preventative maintenance. So we have an exceptionally dedicated operations group who their job is every day, 4 days a week. They do 4 10-hour days. They go and make sure that the telescope and the building, that shutter in particular, are working at the best that they can. At the top there, that disco ball is MegaCam. MegaCam turned 20 this year. It's our wide field optical camera. The picture that is my background here is a MegaCam image. There's a lot of MegaCam images in this room. All of the ones across the wall there have been taken by this camera. It looks at an area of the sky equivalent to 4 full moons. It's our workhorse instrument. And it is lovingly cared for by our instrumentation group, along with all of our other instruments. We have a total of 4. So this happens all night, every night, 365 days a year, except for bad weather. And all of our operations are actually conducted remotely from Waimea. We have a control room there. And it's operated in what's called Q observing mode, which means that no telescope, no astronomer ever touches our telescope. We have professional observers, and so their job is to make sure that on every night we're optimizing the sky conditions. So they might be tonight, MegaCam is on, guarantee you they're looking for asteroids that could impact the Earth. They're also looking at a project that we'll talk about in a minute, and they're looking at galaxies and the formation of the universe and all kinds of really, really wonderful things for astronomers around the world. So we have a new executive director since my last visit. This is Jean-Gabriel Kubi. He is French. This is the photo that he gave me when I said I would like a photo to introduce our new director. It did not have the space background. That was an addition. And so I like, we could do a little bit of a before and after. This is France. This is Hawaii. And so you notice on the top of his head, I'm not sure if you can see it, a Jackson chameleon. And so those chameleons are not native to Hawaii, but they live everywhere. And it is not uncommon in the winter to find that they've snuck into the building and are like sitting on one of the computers for warmth. Now, it doesn't get that cold in Waimea, but if you're a cold-blooded Jackson chameleon, it's nicer on that desktop than it is, I guess, ambient temperature. They do change colors, and they blend into all of the greenery. And so this was a going away party for one of my coworkers. And if you can't see, but the chameleon's posing in the same way as Jean-Gabriel. So he's pretty sure he doesn't know that I put this picture in this doc. He did know when I took it, so that's fair. I also wanted to talk a little bit about some changes in Hawaii. And so the last time I was here in 2020, we were talking about protests that were related to the 30-meter telescope. And in the interim 3 years, there's been a shift in how astronomy is done in the state of Hawaii and who manages Mauna Kea. That's really been at the crux of what a lot of this disagreement, what a lot of this conflict is about. So as of last year, the Maunakea Stewardship and Oversight Authority was formed. This slide is courtesy of Rich Matsuda, who is now the interim director of the Keck Observatory and serves on the MKSOA. So it is a new authority that is responsible for managing Mauna Kea. Its philosophy is that it will put the Mauna at the center of all activities, human and otherwise. And so right now we're in a transition period starting July 1st of this year. It's a 5-year transition moving from the University of Hawaii, which is managed Mauna Kea since the inception of astronomy in the state in 1969. And our current lease and all of the subleases are expiring in 2033. And so we're very excited to be working with and getting to know the members of the Stewardship and Oversight Authority. And hopefully we will start to see at the end of that 5 years, the discussions about the continuation of astronomy in Hawaii. Astronomy is now listed as a policy of the state. Trying to figure out what that means. Everyone is. But it's a very positive thing. And so we're entering a new era of Maunakea management and governance. And this is exciting and interesting times in Hawaii. From there, science highlights, because if anybody has more in-depth questions about the management of Mauna Kea, happy to answer those questions. But I think more of you probably came for the science highlights and whatever all of the interesting things that we're doing at CFHT. Happy to answer questions about all of this at the end. So one of the things we do really well at CFHT is, besides take the full wide field images, is look at the magnetic fields of stuff. And so there aren't many cameras in the world that allow you to study magnetic fields. And so this is a star. It is an artist's impression of HD 45166. Really rolls off the tongue, that name. And so it is a massive star that is a helium star. So what they've discovered, this team from Greg Wade from the Royal Military College of Canada and Tomar from, he's in the Netherlands, they decided, Tomar became obsessed with this star. It's a weird star. And so his question was, what if this weird star has a magnetic field? And this seems like something like magnetic fields. We all know about magnets. This basically looks like a bar magnet. If you've ever done, how many of you have done like the iron filings on a magnet and it makes magnetic field lines? That's what stars do. But here's the thing. There aren't many instruments around the world that allow you to look at the magnetic fields of stars. There are a handful. We have 2 of them. Espérance and Spiru. So Espérance takes the light from one star, breaks it into a rainbow, and allows you to study its composition, its temperature, if it has planets, if it has a magnetic field. And so Tomar was not expecting to find a massive magnetic field of 43,000 Gauss. Now, how many of you are like, oh yeah, a Gauss off the top of your head? No one. 1 or 2. All right. The sun, for reference, has a magnetic field of 1 to 2 Gauss. On sunspots, it might be up to 3,000 Gauss. This, 43,000. And what makes it even more interesting is that it's a helium star. These are even stranger stars that burn helium. And at some point, this star is large enough that it is going to explode into a supernova. But it's not so large that it will become a black hole. It's going to become a neutron star. And so what we have here is the progenitor, the sort of star form of a magnetar. And when this becomes a magnetar, which is a neutron star that has an incredibly strong magnetic field, much stronger than this magnetic field, the question is, how did these magnetars form? They're small. They're a little bit hard to find because neutron stars are dead stars. This isn't something that shines. It doesn't give off light. Stars, the very definition of a star is it makes its own energy and light. And a neutron star is the dead center of a star. Some of them have intense magnetic fields. Magnetars, magnetic stars. Astronomers are not creative with the names. It's a number, or like they mush words together, or it's like a black hole or a white dwarf or a helium star, because it is actually fusing helium. And so this was a very exciting discovery. It's the first one ever. Anytime you discover the first massive magnetic helium star, it's a big deal. Some of you are like, yes. Some of you are like, cool. Sure, it's a big deal. Tomar is very excited. This one is a little bit more, people get excited about exoplanets. And so exoplanets are planets that exist outside our solar system. And so this object TOI-1452b. This is an artist's rendering, just to make that clear. It says it here, but I really want to say the words. We don't know what the surface of this planet looks like. But we do know that this planet is a water planet. And so how do you know that? So again, this planet, TOI-1452b, was discovered using the TESS Space Telescope. And so if this screen is a star, what TESS does is it looks for me, the planet, passing in front of it. And then TESS is like, oh, the star got a little bit fainter. I'm blocking the light. The star got a little bit fainter. And that's all TESS does. It will put an alert that says, hey, TOI 1452 has something orbiting it. And that something could be a lot of things. It could be another star, it could be a cloud of gas and dust, or it could be a planet. And so that's where SPIRU, again, it's a spectrograph, takes the light from a star, breaks it into a rainbow. It does it in the infrared. So Espinon's works in optical light our eyes can see. SPIRU works in the infrared. So we know there was something there, and that gives you its radius. You can actually measure how much the light dipped. It forms what we call a light curve. And they're interesting. They go out, drop off, over. It's what we call a step function. So they drop. And what you need Espinon SPIRU for is to tell you about the mass of that planet. And I like to think of planets as dogs. And I'll explain how this goes in a minute. If I'm a star and I have a small dog, that small dog is not going to pull me on its leash very much, right? If I'm walking a, let's say, mini Pomeranian, I'm not moving. It is not influencing my path at all, this dog. When we think about planets, and the whole last presentation was about the planets in our solar system, we think about the sun's impact on the planet. We never think about the planet's impact on the sun. Gravity's a two-way street. We're not flying up out of the Earth, but we pull the Earth up a tiny amount. Planets, they pull back on their sun a little and cause a little what we call wobble, a little wiggle in the spectrum of the planet. So now if I have that mini Pomeranian, a little planet, they're hard to detect. You can't see what I'm doing. You can't see the dog pulling me off the track. Now my sister was dog sitting a Bernedoodle, Bernese mountain dog with a poodle. Those are big. They're about this big. That dog pulled my mom over. And so that is a big planet. Big planets, easy to find. Little planets, hard to find. This is why there are so many more large planets discovered. They're moving their stars. They're causing their stars to wobble at a rate that you can measure much easier. So SPIRU was looking for the wobble in that spectrum, the wobble in the rainbow of the star. And with that wobble, you can determine mass. Mass over radius gives you a density. And so this planet has a density that gives a really strong case for a water world. Now, we often think of the Earth as a watery planet, and 70% of our surface is covered by water, but only 1% of the mass of the Earth is made up of that water. This planet, we're talking considerable amount of water, possibly even like some of the moons in our solar system. It's in an area that we call the Goldilocks zone, so it's an area where there's the possibility of liquid water. And so now we have the opportunity. Now this is, I think, 100 light years away. So we're not visiting TOI 1452b anytime soon. But now we're starting to discover these smaller planets. This planet is Earth-sized planets that have a considerable amount of water. This gives us questions more about life. Is there life on this planet? I don't know. No one does yet. Because remember, just an artistic rendering. Does it look like this? Maybe. We don't know what the wind is because waves are caused by the wind. We have no idea. Would it have tides? Not sure. We haven't detected any moons. That's smaller than we can see at the moment. But a really interesting actual possible water world. So moving a little bit closer to home, Saturn. There's a constant battle between Saturn and Jupiter when we talk about moons in the solar system. Jupiter was really edging Saturn out in the upper 80s for a bit. When we think of moons of planets, we think about the cool moons. No disrespect to the smaller moons, but we think about the cool moons. You think about Io, Ganymede, our moon, big moons. These are not big moons. These are smaller moons. These are moons that are the size of a town as opposed to moons the size of our moon when we think of a moon. And so this is a result actually from the University of British Columbia. And the student who is no longer a student now, Edward, when Edward was looking for doing his thesis, he started to look at these really wide fields of view. Remember I said our camera, Megacam, looks at a really wide field of view. And around Saturn, he was looking for specks of light that were moving every night. You would look and you would see that this light would move a little bit more. And by doing this and watching how some of their orbits are, he discovered additional moons. So Saturn is now up to 145 moons. Probably a good 70, I think, were discovered by Edward. It was in the 80s, and then Edward took it up to 145. So this is quite the moon count. This is why it gets 3 exclamation points. This is a lot of moons. So if you're looking for something to do, maybe Jupiter. Jupiter, you could enter this. There's a lot of data taken about Jupiter if you want to devote some time to really staring at megacam images of Jupiter in that area and looking to see if lights move, like small little specks of light on these images are moving. You too, with some time and some patience and the support of your thesis advisor, you might also be able to discover moons. So Edward was pretty psyched about this one. Now, I know that there was a talk, although many of you are new, this is your first time at the Discover the Universe or the Center of the Universe. So Euclid, I know there was a whole Euclid talk in June here. I know because my friend Stephen Gwynn gave it and he and I had talked about his talk. And so Euclid is a space mission. So it's going to be it launched into space on July 1st of this year. And so the James Webb Space Telescope, everyone's heard of James Webb. It looks at a really small area and a lot of detail in the infrared. Euclid is looking at a much bigger area of space to kind of give the context to the James Webb Space Telescope. JWST is looking at this, Euclid's looking at this. You need both of them to get an idea of what's going on. Now, when they were designing Euclid, and our current director, Jean Gabriel, is on the Euclid board. When they were designing Euclid, they made some decisions. They made some choices like you do when stuff's going to space. And so they decided that all of the colors of light that our eyes can see, this visible light, would be one filter, which means that you're lacking color. And so with color, we get a lot of information. We get distance, we get temperature. And so there's filters in the infrared. There's one optical filter. And so there were astronomers led by Alan McConaughey down the hill and Jean-Charles Coulondre, who's one of our former resident astronomers, who said, we would like to use, first it started off with CFHT. And then it became CFHT and the Subaru Observatory and another telescope in Hawaii called Pan-STARRS. And they were looking at different colors of light that they could reference back to the Euclid field of view, the Euclid filter. So adding color to the universe. What does color do? Color gives you temperature, color gives you distance. And so in the words of Stephen, it was a quote so brilliant, I wish I had written it, but he gave it to me. It was that the observatories in Hawaii are adding a third dimension to a two-dimensional map of the universe. And so that's what CFHT and the Unions program, and we're observing Unions likely tonight, along with a program, probably if the weather's good, from West Fraser, also down the hill, that's looking, it's called CLASSY. It's looking for objects in our outer solar system. So this is pretty neat. This is a color image of the Union's field. Now we also, you see this thing that's moving through the center here? That is Euclid. And so Jean-Charles decided that it would be a cool thing to see if we could actually take a little movie of Euclid moving. And so it's not actually oblong, but what we're doing here is that the telescope moves at the rate that the stars move. So you notice all of these splotches are not really moving. They are stars. There's one there, and that's probably an asteroid. They're not moving. Euclid's moving very fast, so it's zooming through here. It is not oblong. It's just stretched out because it's moving faster than the telescope was moving. It's going to the L2 point, which is where JWST also lives. Lastly, death-defying planet. So there's a video for this one. This planet's name is Hala. So this was done in conjunction with our friends at the Keck Observatory, and they had this person. So what we see here is this planet somehow survived its star exploding. Here's the planet. Hala just survived the explosion of its star. So there's a couple possible ways that that could have happened. What we're seeing here is if there was a second star. It's possible that when the host planet exploded, supernovae, if it ran into its companion star, that may have been the reason that Hala here was able to survive. And so this is a planet that survived it's known as the death-defying star, the death-defying planet, because normally when you are a star, how your star goes, normally when you are a planet, what happens to your star happens to you. So when the sun puffs up in a red giant in 4.5 billion years, and it stretches out to the orbit of the Earth will be gone, but we don't have to worry about that because that's 4 followed by 9 zeros. That's not happening anytime soon. But Hala here, it somehow survived. And so astronomers are trying to figure out exactly why. There's 3 different options. I showed you one of the 3. If you want to know about the other 2, see me later. So moving to some technical upgrades. These are our strategy for the next 10 years. And so basically what we want to do is continue to engage with the community, which is what I do, raise awareness in the broader astronomy community about the importance of Mauna Kea. I will get to MSc in a moment, so I'll pause on that one. And then continue our successful scientific operations with some tweaking of existing instruments. So I mentioned Espinons. Helped with the magnetic field. I mentioned Spiru. It discovered that planet. It gave us the density of that planet. What if you could use them both at the same time? Now, how many of you are professional astronomers? None. How many of you are like, but even I know it's cool to use 2 things at once? Right? And so that's basically what people are very excited about. What? I can look at light from all the way to ultraviolet into the infrared and maybe be able to do it at the same time. Cool, guys. That's really the response we're getting, but with a lot more exclamation points. Our MSc, I realized I put these slides out of order. So MSc is our Mauna Kea Spectroscopic Explorer. It is our plan to upgrade our facility into a larger telescope on the exact same site. Actually, let me do this. A larger telescope on the exact same site. And so we're working on this. But in the meantime, we're working on a pathfinder, something that's going to lead us from CFHT here to MSc here. I had to take a whole bunch of steps to be able to get there. And Pathfinder is what we want to do to be able to do that. So we're exploring some options, looking for some funding, and are pretty excited about the possibility of this instrument. Please ignore Casca 2023 Penticton at the bottom. I borrowed this slide from my coworker. And on this one, you see here, we've got this Sam Barden. He received a National Science Foundation grant to be able to develop some of the tools that we're going to need for this MSc. And part of that grant was money for a student. So this is a job ad. Sorry, this is a flyer for dinner that I'm missing. And I don't know if there's more attractive words than looking for an internship next semester, interested in optomechanical design and production. Apparently, if you are an undergrad at the University of Hawaii College of Engineering, 10 of them have already signed up for this dinner. So we're pretty excited about that. We don't know if it's a free dinner or if they're really interested in optomechanical design and production. We'll find out. And so why I put this up there is this directly loops back to that vision that I mentioned earlier about, continuing to engage and really work in authentic ways with the community and making sure that we do the best that we can when money like this through national grants come into the state, that money is going to work with local students. Which segues nicely into my actual job. 1, explaining space to people, see all of the previous slides, and 2, how I do that. So in my introduction, Ben mentioned that I run the Maunakea Scholars program. It is a program for Hawaii public high school students to apply for observing time on the Mauna Kea observatories for their own independent research projects. And if I've said that once, I've said that a million times. Of all of the things that I do in my career, this, no matter what else I do, will be in the top 5. I've got a couple others that I'm exceptionally proud of, but this program I'm exceptionally proud of. And so at the top there is our former director, Doug Simons. He's now at the University of Hawaii Institute for Astronomy. They are a partner in Maunakea Scholars, which means that he still gets to give out certificates. Now, the reason that everybody in that photo looks really like she looks so excited is Doug's just told her that she's going to receive a $10,000 scholarship. So that is Sienna Lay. She was our first Maunakea Scholars recipient from Kamehameha Schools, which is a school that is for Native Hawaiian students. And she's at Yale right now, majoring in astronomy. And the goal of this program is not to have a million little astronomers, but to empower students to see themselves as people who can do STEM. And so she was interested in astronomy. These 3 students down here are also Maunakea Scholar students. They are interested in the project. They're interested in Pluto. They're all high school seniors. None of them are interested in majoring in astronomy. So this is May, Kyla, and Miley. We were observing a couple weeks ago. And so these are their observations. They were interested in Pluto. Pluto's above, right below the Pluto label, so I wouldn't forget. I was at high altitude. And then next to that is observations for another group, that's Saturn. You notice there's no Saturn, it's only rings. The color of light that we were looking at is completely absorbed by Saturn. And so you don't see the planet, you only see the rings. And so they want to, we've got, I think forensic science, international business, physics, math, or computer science or astronomy. That's what those ladies are interested in. So if you go through this whole program and you're like, yeah, astronomy, that's for me, then there is the opportunity for a scholarship. So our first student who was a Maunakea Scholar just got his astronomy bachelor's degree in May, JC. And so I'm exceptionally proud of all of them, but JC is the first one to actually go through and get a degree in astronomy. These are summer interns. So you'll notice there's 2 separate photos. This is the Akamai internship. This is Noah. This is Dell. We worked with them all summer. And so Noah finished his project in 2 weeks, a 7-week internship, because it turns out that there was a way to do it faster, that once he started, he was updating, there's a tool that we use that one person looks at the website for. And so if one person's looking at the website, it kind of doesn't matter what it looks like. But Mark would like other people to look at this website so that he doesn't have to be the only person. So Noah's job was to take information from this camera that we have and make it much more user-friendly. But the thing is that someone in our software group had code that would do that. So Noah then created a very in-depth analysis of the data from this camera. And Dell over here, he actually built, designed, and installed a tool that when our large camera Megacam comes down, people don't get their fingers pinched. It seems like something we would have already had. We didn't, which was an awkward question that he had to answer at his presentation. Now, the reason that these kids are separate is that I, at one point or another, have worked with all of them while they were in high school. Amanda and Kyla received telescope time through Maunakea Scholars, and Xavier won our science fair project. Because, again, This is the Brock edition. The reason it's the Brock edition is Brock just had his poster on using a convolutional neural network with all sky infrared images to classify sky regions as clear or cloudy, accepted at a professional conference, the ADAS conference. And so this is Brock this summer. If you look directly above him, that's Brock in 2018. So I have known Brock since he was a sophomore in high school. And when you've known someone since they were 15, you can put pictures like this in your doc. Those are school events. This is more school, but on the community side. What we do at the first day of school every year, we are directly across from the elementary school. And so this is Helen, Greg, and Arturo. It was a very windy day, or we would have had a tent. We were passing out school supplies for the students that go to the school directly across the street. We also had donuts. All of the parents take donuts on their way back, so the kids don't see that they take donuts. All of them say that they're modeling healthy behaviors, and they take the orange on the way over. And then on the other screen, you see a man with an omelet pan. That is Rory Souza. He is the principal of Maunakea Elementary School. So I'm on the school and community council for both of these schools. And the first day of school every year, Rory makes omelets for the entire faculty and staff. I had my waffle iron privileges restored this year. I lost them one year because I was talking too much, and I got behind on the waffles, and you do not get behind on the waffles for Mr. Souza. So this is just a sampling of the kinds of stuff that I do. I'm happiest when I'm explaining space to kids. As I say, sometimes you have to explain space to adults, and that's when you need PowerPoints. So this is a very old picture of our staff that really should be updated, but this just gives you kind of an idea of all of the people who work at CFHT. Now, if you want to learn more, you can follow us on social media, go to our website, or you can just email me, because yes, I just give my email address out all the time. So with that, I saved enough time for some questions.
Thank you. If anyone has any questions, I'm going to need to bring the microphone to you so you appear on the recording for posterity. Okay.
You didn't mention that your mirror was made here in Victoria.
I did not.
Yes, the mirror for the Canada-France-Hawai'i Telescope was figured and polished here in Victoria between 1974-75 to 1978.
Thanks, Dennis.
I was there.
Still took 4 years, right?
I'll just take that for a moment. So Dennis was a resident astronomer at CFHT in 1983.
Anyone else? Going once?
They either gave so much information or too much information, an overwhelming amount of information.
I think I do have a quick question.
Okay, Kellen?
I did want to quickly ask about that one instrument you said where you just take two existing instruments and then do them both at the same time. So are you just dividing the amount of light you get up in half, or are they somehow getting both of the light?
Yes, to both of those. So they look at different colors of light. Please ignore, like, this is the technical diagram you need to look at. This is Spiru. This is Espérance. This looks at light your eyes can see. This looks at the infrared. So there is something called a dichroic, which is a piece of optics. We'll just call it that. It's a thingy. We're going to go real technical. There's a thingy, and the thingy will split the light between the optical light, which will go here, and the infrared light, which will go there. Now, if it was that simple, it already would have been done. So we're in the process of, we know we can do it. It is going to be done. Greg, you guys don't know Greg, but Greg's on it. Greg's going to have this working for us by, let's say 2024. I mean, it's September, so maybe I should say mid 2024. I forget what my official timeline on the more technical presentation has. It's also getting a better name, because no offense to the people who named it Vision, Greg and I don't like that name. And so we're working with high school students who go to a Hawaiian immersion school, Navahi. They're part of the Ahua Hea Noa, which means in Hawaiian, to call forth to create a name internship program. And so when you name something in classic Alelo Hawaii, you name it based off its characteristics. What is it? What does it do? What's its purpose? And so we'll be working with the students this semester to have a better name than vision. So hopefully the next time I am here, this will be working and it won't be called vision. It'll have a more poetic name. Like if you've heard of Oumuamua or Povehi, those are both names that were created through this project.
Okay, thank you very much. You get a whole 15-minute break. Oh yeah, the swag.
You can come up and get stickers. So we've got 2. I'll find the third. So we just did them by color. So the blue ones are hot young blue stars. The gold ones are looking towards the center of our Milky Way. And when I fish the pink ones out, they are a star formation region. So if you have any other questions, and you can just come on up and ask. Sure, I have 12 minutes, but I don't actually need all of them. So you can come on up and ask questions if you'd like. Thank you guys so much.
Hi, everyone. Welcome to What's Up in the Sky for September 16th, 2023. Be sure to check out our gift shop in person or online. And note that we don't have exactly the same stock online that we do in person. You can find some other items in person, so be sure to check it out in person if you can. And we're grateful for your memberships and donations, which help keep our educational programs running. And note that we still have summer daytime hours, so stop by and say hi. And we'll be doing dome tours and planetarium shows throughout the day. Summer daytime hours continue to September 29th and are Tuesday to Friday from 10 a.m. to 3 p.m. And note that we're not open on Saturdays due to staffing issues. So there is an admission price for that. So we do charge money to raise, to raise money for our educational programs. And it's seniors age 65 and over is $12. Adults age 18 to 64 is $15. Students age 18 to 25 with valid student ID is $8. Youth age 7 to 17 is $8. And children 6 and under are free. And it's also free for the Wasanic community as the observatory sits on their traditional territories. So a little bit about sunset and sunrise. Sunset was at 7:24 p.m. tonight. Sunrise was at 6:51 a.m. And the sun was at its highest point at 1:08 p.m. at 44 degrees above the southern horizon. And on the equinox, it will be 42 degrees above the horizon. So a little bit more about the equinox. The equinox this year is on September 22nd at 11:50 p.m. local time. That's here in Victoria. And the autumnal equinox in the northern hemisphere is when the sun appears to move into the southern part of the sky. So, and you can think of this as another way. The sun is directly above the equator of the Earth at that time, and the Earth's axis is at a right angle to the direction of the sun. So it's kind of turned sideways, if you like. So note that it is still quite warm, and while the sun is at the same altitude in our sky as in the spring equinox, the autumnal equinox is pretty much always warmer. And let's just have a look at how much warmer. And this is the time and date website, excellent website. And here you can see some historical climate figures. And for September, it historically has ranged between 9 at a minimum to 20 degrees at a maximum on average. And if we just scroll down a little bit here, we can see the mean temperature is 14 degrees in September. And in March, though, it ranges from 3 to 11. And so that's quite a bit lower. And so the mean temperature then is if I can just find this here, is about 7 degrees. So it's I think you'll agree that that feels substantially cooler. And so that is quite a noticeable effect. And a little bit more about the equinox. If you look carefully at the length of the day and length of night for the equinox, so on the 22nd or say the 23rd, you'll see that it's not a perfect split between the amount of light and the amount of darkness on that day. And part of the reason is the way that the day is defined. So the day is said to begin when the first little bit of the sun peeks over the horizon, and the last little bit of the day is when the last sliver of sun goes below the apparent horizon. And so the timing is distorted a little bit because the Earth has an atmosphere, thankfully, and that atmosphere causes the light from the sun to bend over the horizon. And so really the time when we do have equal day and equal night is a few days later. It's actually on September 25th, so about 3 days later. And that actual time of equal day and equal night, as observed by the number of minutes, if you like, or seconds or hours, is called the date of equilux, not equinox. So a little bit of terminology for you. So if the most northerly positions of the sun and southerly positions of the sun fall on the solstices, and when it's halfway between that's the equinoxes, are there any other special dates? And these are actually called cross-quarter dates, and they fall halfway between the solstice and the equinox. And so Halloween is the next one coming up, and that's the fall cross-quarter day. In the Celtic tradition, that is their end of summer and also the beginning of their next year. And Groundhog Day is on the one halfway between the winter solstice and the spring equinox. And May Day is another cross-quarter day. And August 1st is another cross-quarter day. And we don't really have a well-known day for the summer one, but in BC, you notice that in BC Day falls very close to the summer cross-quarter day. Okay, so I'm just going to share my screen here, and hopefully, and show a little bit about what's happening with space weather. And so I'll just get that up on the screen if you can bear with me. I imagine there's some music playing in the background or something, and for entertainment. Okay. So keep your eyes peeled on the site, spaceweather.com, because they're predicting there's a chance of aurora happening on this Sunday night. And these things are really hard to predict. I can't say that you should make all kinds of plans to go out and see it just yet, because they're quite fickle, and they do affect our weather. And so this is space weather, at least, certainly. Signals from satellites, satellite transmissions, that sort of thing. So it's of great interest to scientists, but we haven't been able to quite pin it down as to whether we're going to see a big event or not. So what you can do is, close to when it gets dark tomorrow, is look for the aurora oval and see if it appears to be covering Vancouver Island. And typically the KP index over here on the left side of the menu will be above 5 when that's happening. So that'll be around maybe 6 or 7 when it's covering Vancouver Island, and then you have an actual chance of actually going out and seeing the northern lights. All right. And so just keep your eyes peeled on that all the time. Check every day, and you should get some interesting predictions for seeing it. I know it's on many people's bucket list to see the aurora, and it is possible from here in Victoria. You just have to be kind of alert to watching this website for that. Okay. Also keep your eyes peeled on spaceweather.com for exciting photos of the annular solar eclipse in October and other events with solar activity. So that's kind of cool. I'm looking forward to that. And the moon phase right now is just past new, and it's a thin crescent at the moment of about 3 or 4%. And looking outside, I think it's a little bit doubtful that you'll be able to see it because of fire smoke. We'll talk a little bit more about that in a second or two. The first quarter moon will be on the equinox, and the harvest moon will be on September 29th. And if you're like me, you might play Neil Young's song by the same title on your guitar, or simply listen to it on YouTube or something like that. So that's an annual tradition for me. So the Wasonic people, upon whose traditional territory the observatory sits, referred to this moon as the dog salmon moon, and that's when the dog salmon would return to spawn, as the rivers had deepened enough due to rain for the salmon to go upriver and spawn. And of course, we're in this very deep drought, and we're not sure that the rivers are deep enough for that right now. So let's hope that we get some rain, and that happens soon. And I might be able to put the Wasonic site up here on the screen in a second or two, if you bear with me again. So just imagine that Neil Young's song is playing in the background for entertainment as I do this. And this is the great Race Rocks site with the 13 moons of the Wasonic. And you can see them all listed here. And there's all sorts of interesting things that are associated with each moon, such as their economic activities and things to think about, and so on, and also weather. Okay. All right. So fire smoke is still affecting our skies, as I was just saying, here in Victoria. And currently the fire smoke that we're getting right now is coming south from the Olympic Mountains. And so in addition to weather reports, we're now having to check, if we want to observe, we're now having to consider fire smoke as well. And so let me just see here if I can put up a good site for checking that. And getting a little faster at this. So this is firesmoke.ca, and this has, if you click on this figure over here, you can get up-to-date forecasts for the fire smoke in your area. And there you can see, if you zoom in here, you can see where the fire smoke is that's affecting us right now. Okay. There's another great site that I often check when I'm observing, and I'm going to see if I can put that one up. And this is called Clear Dark Sky. And just flip over to that. And this is an interesting one. And this is actually built on data that's provided by the Canadian Meteorological Centre, so basically the Government of Canada, and it actually will let you know what the expected cloud cover is, and also the transparency of the sky. So it actually takes a look at how much moisture is in the air and whether we're going to have a lot of haze or not, and also seeing down here. And you can see that that this is an indication basically of the amount of turbulence in the atmosphere. And so if it's a dark, what you're looking for really here is a dark blue on these. And if it's lighter than that, then you're not really going to get a good view of things. So it would seem that the transparency might not be so good. And this doesn't yet take into account the factor of fire smoke, but I imagine that it will in the future. Unfortunately, we'll have to consider that as well. Okay, so I'm going to fire up Stellarium here and share that with you in a second or two. And so Saturn rises in the east at around 6:43 p.m. and it's becoming very well placed in evening skies right now. And I'll share the screen with you in just a second or two. Okay. And just bear with me. All right. So here we can see a view around 8 o'clock at night, 8 to 8:49. I'm just going to get rid of the meteor showers because there really aren't any any exciting meteor showers right now, but you can see Saturn is up there low in the southeast. And so it does look like a fairly bright star, even from the light polluted skies of Victoria. And but so you'll get a reasonable view of it. Jupiter rises at about 9:08 p.m. now. So that's over towards the east. There you can see it, and there you can see that the planet Uranus is fairly close to it in the sky, and you should be able to see the planet Uranus in binoculars, but you'll need it to be higher in the sky than this typically. And when a planet is down this low, you're looking through a lot of air turbulence, and you're also it also tends to obscure a lot of the light. So you get a better view of it when it's higher in the sky. So I really recently wondered, like, because these planets are actually fairly low in the sky, like when will they be up high in the ecliptic, when in the winter skies? And we'll have to wait a few years for that, but certainly the views of Saturn, for example, in about 5 to 7 years will be fantastic in the winter sky. And so we'll be looking through less air turbulence in those years. So I'm looking forward to that. But Saturn always impresses through a telescope. And my grandniece recently had her first look at Saturn and went, "Wow!" through a telescope. So that's really great that even now it still impresses people. Okay, so it's actually kind of worth pondering just what we can see up there. So in the nighttime sky, we have these various factors now. We have fire smoke, and we have light pollution, and so on. And I've pointed out that fire smoke has been the biggest factor this summer in obscuring our views of the nighttime sky. And light pollution here in Victoria is also a factor, and it's not really improved in the last dozen years. And part of the reason is because of LED lights have become so cheap, it's really easy for people to string them up in their backyard or what have you, or to make signs with them and to run them all night at very little cost. And so while there are more lights with covers over the top, and you can actually request that for your neighborhood streetlight if it's shining onto your property, for example, the city will actually put it up there for free. There's advances like that, but there's so much artificial light out there right now that it's actually quite a problem. And so what I'm going to do here is put up a little bit of a view of some simulations I did on Stellarium. So just bear with me as I bring these up. I say that a lot on here, don't I? I say, bear with me. Okay. And this is a view of the northern part of the sky viewed from a place like Beacon Hill Park here in Victoria. And what you notice is that you can't really see too many stars. It does kind of help in a way in that it's easy to identify groups of stars or asterisms like the Big Dipper here. You can see the pointer stars pointing up to the North Star up here, and kind of see the bowl of the Big Dipper there and the handle and so on. But you really can't see much of the nighttime sky. So what could you see if you didn't have fire smoke and if you didn't have light pollution? So say if you're up in the north end of Vancouver Island or something like that, well, you get a view more like this, and minus, of course, the labels on the stars that you see up there. But one thing that you start to notice is that in a really dark sky like this, so-called Bortle 1 site, where there's very little light pollution, you also find a view like this, say, in the Rocky Mountains near the Columbia ice fields or something like that, is that it actually starts to be hard to pick out the patterns of things like the Big Dipper because there's so many stars up there. And so if you had eyes as big as an owl, for example, if you had eyes as big as an owl, like my little friend here, what would you see? Well, that's a really interesting little thought experiment. And in fact, it would be virtually impossible to pick out the constellations because the sky would be so crowded with stars. The one thing that's wrong with this simulation here is the ground looks dark. But of course, with this much light coming down that the owls can use, the ground would look brighter to them. And this is why their big eyes help them find prey on the ground at night. So we can't make our eyes any bigger, but of course that's what binoculars and telescopes are. They're extensions of our eyes that make our eyes effectively bigger. And unfortunately, they don't give a wide angle view of the sky like this, but we can probe into little sections and see some of the wonders that are out there. And so this is just really with a fairly small aperture of the size of an owl's eye and the sensitivity of that. But with large telescopes that are, say, now getting up on the order of 30 meters and so on, you can just imagine what can be seen out there. And there is a limit to the number of stars that we can see. All these stars are actually in our Milky Way galaxy. And in a view like this, for every single star here, there's about 3 million more, I believe off the top of my head, in the galaxy. Even with a big telescope, there is a limit to how many stars you can see. They get very crowded, but beyond that, we see the galaxies, and then the sky becomes very crowded, and it's virtually galaxies everywhere. And there's about, we estimate that there's something on the order of about 3 to 10 trillion that are out there. So that's, a trillion is a million times a million. So a little bit to think about as you're looking up at the nighttime sky. So those big empty spaces between the stars that you see are really not so empty at all, but are more of an effect of our eyes and our observing conditions. And as for sleep, which we talked about earlier, one of the best things you can do is take an afternoon nap. And I just happen to be reading this great book right now called Why We Sleep by Professor Matthew Walker. And as he says, our natural sleep pattern is bimodal, which is means to take a brief afternoon nap, and then a longer sleep of about 8 hours at night. And he points out that the urge to sleep builds up gradually over the day. So it usually starts at about 7 a.m. and it's caused by something called I'll probably mispronounce this, but adenosine. And so it creates effectively kind of a pressure in us. And so you can lessen this sleep pressure by taking that midday nap. And so it kind of resets it and it has to start up again. But for anyone doing the night shift, whether as an amateur astronomer or as a worker, that staying up late at night is just not that good for you. But nevertheless, I hope that you do get some clear skies that are free from fire smoke over the next week. And I think we'll be taking a little bit of a break with the Saturday night programs, but we'll be coming back probably sometime in the fall for occasional sessions. So that's it for now. And as always, keep looking up.